Hey, you 12s, welcome to Friday's lesson, and congratulations, this is the last exercise of further maths for you guys this year. If you haven't done 9.4 and 9.5, stop this video right now and go back and do it. Right, now that you've done 9.4 and 9.5, let's check out 9.6, which is dealing with transition matrices with restocking and culling. So previously in 9.4 and 9.5, what you noticed was with our truck example, the company always had 140 trucks. All right, so remember how Depot A had 105 and Depot B had 35 once we hit that equilibrium state? Well, the difference between 9.6 and 9.5 is, let's say that truck company decides to expand, they might buy more trucks or sell off old trucks. And this is where restocking and culling comes in. So in the truck context, restocking would be buying more trucks. Culling would be selling off their trucks. But our example today, we're going to take a look at a company that produces fish, I'm pretty sure. I'm just going to Google what Whitings means quickly. But what you can see here is, in grey, there's a really important statement. And the statement goes, unlike 9.5 and 9.4, there's no there's no formula that can find every single solution for you. All right, so for 9.6, whenever we make changes in our stock, we have to work it out year by year by using recurrence relations. Let's begin. So here's our generic formula, which we're going to get used to in our example. You can always come back to it once we're done with the example, and hopefully it'll make more sense. But what we need to do again is, with these really long-winded questions, you got to highlight the keywords or key details. In yellow, we're going to start with the first paragraph. A company wishes to start a commercial whiting breeding farm. So whitings, I just Googled, are fishes. And it starts with 20,000 whiting eggs, 4,000 baby whiting, and 500 adult whiting. Now you're probably wondering, Ed, why are you highlighting it all in yellow? Because this is our S0 matrix. This is our initial matrix, okay? And what you find down here is our S0 is always what we start with. And the 20,000, 4,000, 500, and 0, we'll figure out why it's 0 in a moment. All right, but that's what we started with. So the following details after the first paragraph says, the following could happen in a year. Eggs could die, or they could become a baby whiting, which is labeled B, and death is D, and eggs we've got in E. Baby whiting B could die also, or they could live long enough and become an adult whiting, labeled as A. Adult whitings could die, or they could live for a while, but eventually they will die, which is the sad reality. It's just like us. From one year to the next, this situation can be represented by a transition matrix T, where if this is the year that we've got the original starting eggs and baby whitings and adult whitings, well, the next year there's going to be some deaths. There's also going to be some newborns. So what they're saying in this transition matrix, if we call this from memory, I think we had our transition matrix as green. I'm hoping it's the same as exercise 9.5 and 9.4. What it's saying here is, if you have an egg, well, the next year there's a 30% chance they become a baby, or there's a 70% chance of death, which is unfortunate. But once they make it to being a baby, there's a 35% chance they make it on into adulthood, but there's also a 65% chance of death. Once you're an adult, you either keep living at a 60% chance, or there's a 40% chance that you die. And once you're dead, that's why it's a 1. All right? There's no coming back from the dead, and that's why you've got zeros in the following above elements in the top right. So I'm hoping this sort of makes sense so far. This is sort of always going to be given to you. The transition matrix T is always going to be given to you. They're never going to ask you to create a transition matrix unless it's like 9.4 where they have a network and they show you the network and then you got to place the values into the matrix. But for these sort of questions, I'll always give you the transition. What other questions might you guys have? Right, this part. So just below, the company removes 500 adult whitings each year to sell to restaurants, adds an extra 200 baby whitings each year, and estimates that 8,000 extra eggs will be laid by the adult whiting during each year. It establishes a population of whiting can be modeled by the recurrence relation. The starting amount, we've got 20,000 eggs, 4,000 babies, 500 adults, and no deaths. This is saying, well, the next year is going to be the transition matrix times the previous year's total fish quantities plus this B. And so the first question says, find B. Well, what do you think B is? If you answered B is going to be the adjustments they make each year, you are spot on. So this is a new one. This is new to 9.6, and this is a part that we're going to create a new color for. Which color haven't we ever used before? No, there's no more ink colors. Now let's use dark gray. If there is a dark gray. Mild gray? No, mild gray's light, isn't it? Anyway, so what you notice is the company removes 500 at, that's a terrible color. We've used orange in the past, haven't we? Ooh, that's kind of gross. Let's use that. So we know the company removes 500 adult, whatever. That's just gonna, goes 200. But no, it's got to show. We can't have this situation where it doesn't show. Because it's important, we're going to go with this baby blue. All right, so 500, 200, 8,000. Now, what did we just highlight? Well, the 8,000 are the extra eggs, so that's why it's up top. So at the end of each year, the company adds 8,000 extra eggs to their farm, and they also add 200 baby whitings. Well, they probably buy them, and then they sell off 500. So this remove part is important as well. What? Yeah, there we go. All right, and so that's why we've got a negative 500 there. All right, and then we've got 0. And this covers off our B section of the formula. Now, do we know the T? Absolutely we do. The T is our green transition matrix. Do we know the SN? Well, yeah, we do for the first year, because the first year, all right, this N+1. So if we have S1 here, well, what's before S1? Before S1 for the SN is going to be S0. So we do have our SN, but this SN is always going to change. All right, if you did the recurrence relations from 9.5, you know this is dynamic and it'll change. But to start, it's always going to be the S0. All right, let's take a look at why. So now that we've got our B, we've got the rest of the formula sorted, we can take a look at part B. So find the number of adult whitings after 1 year. What we need to do is, remember that formula we just highlighted where we had S0? If you don't remember, it's literally what we just looked at, and I've copied it down below. That's our S0, the amount of eggs, young or baby whitings and adult whitings that we started with. Our T is our transition matrix that's given to us already. Our SN in the first year, if this is S1, then this SN here will be S0. All right. Again, we'll talk about that just a moment after I highlight the B with our baby blue. So, find the number of adult whitings after 1 year. So if this is our task to find the number of adult fishies the company has after 1 year, we replace this SN plus 1 with S1. All right, don't worry about the N plus 1. Well, like people always get hung up, like, what does N plus 1 mean? All it means is the year you're finding. Okay, and from there, what we can say is, well, we know the transition matrix. The transition matrix was given to us in the question. If you're not sure where to find it, we'll scroll up, and what you notice is the transition matrix was back up here when we were reading the original detail of the question. All right, so transition matrix is given to us. That's represented in T. The SN just means, well, if this is S1, what's before S1? Before S1 is S0. If this was S2, then this would be S1. If this was S3, this would be S2. Okay, so whatever value in the subscript is here, this matrix here is always going to be the year befores. And the year befores in our scenario here is actually the S0. And so this is why we've taken the S0, and this is why we need the S0 to be able to find out year by year what the amount of adult whitings or eggs or deaths or babies are going to be. Without it, we just can't do anything with the formula. And then lastly, we've got our baby blue, which is the adjustments that we figured out in part A of the question in the matrix like so. And again, this detail here was given by the question. Just trying to think what sort of questions you have. You might wonder why it's in 8,200, negative 500 and 0. Well, if you look at the 8,000 extra eggs, in the transition, eggs is first. Right? If you look at the 200 babies, well, babies is second. That's why it's in the second row. If you look at adults, where it removes 500, that's why it's third, and then deaths is last, and we don't have any deaths to start with. That'll just be terrible if you bought a dead fish. It's bad business. So yeah, so that's how we got the order. It's always eggs, babies, adults, death. What other questions might you guys have? Where did this time sign come from? The time sign is because T and SN next to each other implies times. Where did this plus come from? The plus is just from the formula from above. Where did the formula come from? Formula came from the question above. I think I've covered all bases. If you do have questions, please keep sending them through. And so what you do now is we've got the matrices. We do our bid maths. So just like normal numbers, we have to get rid of the multiplication and division before we get onto the addition and subtraction of matrices. You input this and input this into your CAS by recreating them in your Scratchpad. And what you do is, once you've recreated it, press enter. Don't forget the time symbol in between, and you'll get this matrix down below. We carry this down, so the baby blue of what we adjust each year downwards with us, and that'll tell us the answer once we add the two matrices together. So what we have here is, well, 8,000 plus 0 gets us 8,000. 6,000 plus 200 gets us 6,200. 1,700 take away 500 gets us 1,200 because plus minus, the minus overrides. 16,800 take away 0 gets us 16,800. What did we just figure out? We figured out there's going to be, at the end of the first year, 8,000 eggs, 6,200 baby whitings, 1,200 adults, and 16,800 whitings are going to perish. And the question, remember, says, well, how many adults are we going to have? Remember, it says, find the number of adult whitings after 1 year. If we label the matrix like so, we can see the top row is eggs. The third row is adults, and we can see there's going to be 1,200 adult whitings remaining. Questions you guys might have? Nope. So if you got a SAC question or exam question where it says a company like this sort of scenario, and they said find the amount of deaths after 3 years, you have to physically figure out year 1, year 2, and then year 3. So there's no shortcut to this like in 9.5 with our truck example. So whenever you see recurrence relations, really tedious. There's always going to be an S0, a starting point, and then you work it out year by year, month by month, week by week, whatever the context of the question is. Part C. Now it's saying find the number of adult whitings after 2 years. After 2 years. And what we need to recognize is we still use that same formula like we did in year 1. Initial starting point is still the same in year 0. Our SN plus 1 is now S2 because the question is asking us for after 2 years. Our transition matrix stays the same. All right, so this matrix here stays the same. Whatever. It's a little bit off the bracket, but you get the gist. And then our SN is actually going to be different. So let's not confuse the T with the SN. What do you think the SN is going to be here? Is it still our S0? No, it's not. Now, remember this answer back here where we had the answer after 1 year. Let's call this the red matrix, the year 1 matrix in red. This is our S1 answer. Now, because we have an S2, so previously here we had an S1 because we're figuring out after 1 year, and then this was S0. S2 means, well, we can't have S0 anymore because the brackets or the matrix that we have in here has to be the S1 matrix. And this is why recurrence relations, we've got to find out year by year. Without finding out year 1, we don't know what this matrix is going to be in this position. All right, so that's why it's super tedious. So where we got this SN matrix for the for this second question is from part B. Okay, so it's literally from that matrix from above in part B where we figured out after 1 year. Our B is still our baby blue matrix. That tells us what they're going to do as a company at the end of each year. They're always going to buy 8,000 more eggs, 200 more baby whitings, and they're going to sell off 500 to the restaurants for them to eat. Now, once we've established this, we can recreate this situation in our CAS. So recreate the two matrices, multiply them together, and what you get is, or hopefully is, this matrix down below. Once you've got this matrix, you drag down the baby blue one, which is the changes the company is going to make at the end of each year. And so do some simple arithmetic: 8,000 plus 0, 2,400 plus 200, 2,890 take away 500, 26,910 plus 0. What you get is this matrix down below. So here we have, after 2 years, 8,000 eggs, 2,600 baby whitings, 2,390 adult whitings, and 26,910 deaths. Let's give this a color also. What color haven't we used? What? Is there a good orange? Orange is good. This is what we get after year 2. Right. So if we have to find year 3, we would take this year 2 and plug it in to the red part, the SN, or in example B, the yellow part. So hoping you guys understand what's going on. So again, the question here was asking for the number of adult whitings after 2 years. And after 2 years, there are 2,390 adult whitings based on the third row of our matrix that we found out in part C. Part D says, well, instead of just removing 500 adult whitings after the second year, the company decides to remove enough so that the number of adult whitings remains the same as it was at the very start. How many do we need to remove after the second year? That's a key detail in this question. Well, what does this instead removing 500 mean? If you said, back up here in our baby blue, the restaurant at the end of year their plan was to cut or sell off 500 adult whitings to restaurants to eat. But after the second year, they're like, nah, we don't want to sell off 500 anymore. We want to sell back to what we had in the beginning. Who remembers what they had in the beginning? Don't read this. If you said they had 500 to start with, you are spot on. If we go back to the origins of this question, okay, what they started with was 500 adult whitings. So the company is saying, well, after the second year, I want to sell off all the whitings up to the point where I have 500 left, because that's what we started with, and that's what the question was asking. And what we do here is, well, to get back to 500, we need to take away what we have in storage at the moment. So at the moment, we have 2,390 adult whitings. We've established that they originally started with 500 adult whitings. So what they currently have, deduct what they want left, is how much they need to sell off to restaurants, which is 1,890 whitings. So to phrase that into a sentence, to get back to 500 adult whitings, which is what they started with, the company needs to remove or sell, sell's a better word, 1,890 adult whitings. All right. I mean, I guess I could kill off that many whitings, but that's bad business, so that's why we're saying sell. The last part of further, how exciting. The company decides to start another farm. So now they're expanding under exactly the same conditions, but with one change. The breeders realize that the number of eggs laid by the adult whiting during each year depends on how many female adult whitings they had each year. Makes sense, right? Females have the eggs. They come up with the following modified recurrence relation, where they estimate 50% of the adults each lay 200 eggs a year. So what does this all mean? Well, this business, they still started with the same amount, I'm pretty sure. Let's just double check. 20,000 eggs. Did they start with 20,000 eggs? Yeah. So their stock start is still the same. So this S0 is still the original. Okay, so this is still the same starting point as above. But what's different now is they want more females. And to do this, what they give us is this formula of sorts. So here we still have the transition matrix. Okay, here we still have the SN that changes year after year, but then we've got this sort of situation. So this business here, they're not going to buy any more new eggs. They're relying on female births to lay 200 eggs a year. And so what they're hoping is this 200 eggs then becomes babies. All right. So once they become babies, they can then become autonomous, and then hopefully they survive into adulthood. But they still sell 500 to the restaurants. Okay, so that's why it's slightly different. If we take a look above, previously they used to buy 8,000 eggs. They no longer do that anymore. They just buy the 200 baby Whitings, and they sell off the adults still to the restaurants. So where this came from is, well, if they lay 200 eggs a year, possibly they're estimating only 100 will survive. I think that's where the 100 came from. But generally, this is the formula they give us. And what color did we have? That was baby blue. So we have a new baby blue matrix. So this is what their business plan at the end of each year is. And then they've got this extra detail, which we are going to call indigo. And then lastly, we've got the SN again. So please don't forget there's two. A lot of people often do. And so what we do is, well, we got to answer the question. The question says, how many eggs will there be after the first year using this model? All right. Well, the first year is going to be our S value, S1. So if our SN plus 1 is S1, what do you think our SN is going to be? If you answered with our S0, you are spot on. Okay, so our SN here is going to be the S0 because the number before before 1 is 0. And we've got the starting matrix here already. And what you notice is, remember, we've got two of these. We've got two. This T here is our transition matrix. This was way back at the start. That was given to us already. May as well highlight this part in yellow too, because, well, not that we've not already done so. We'll highlight the SN plus 1 as purple. Right, and then, well, where does this come from? Well, this was our, well, this is a new business plan that the company's going to use. They're no longer buying eggs, but they are still buying 200 young babies and selling off 500 to the restaurants. And this here is the rough estimate of the number of eggs that the adult population of their company is going to produce, which is roughly 100. So if we leave this one as indigo, what we can do is we can hopefully trace where all these pieces of information came from. Again, if you don't understand, please let me know. Oh, this is tough highlighting. Got to zoom in so we don't overlap. Thanks for your patience. Right, now that we've established where all these matrices came from, the easy part now is to just input the multiplication matrices together So you're probably wondering, well, Ed, how did we get this time sign when it was TSN? It's T times the SN matrix. So the transition matrix times the matrix in the year before, or the quantity we had in the year before. Likewise here, this indigo here is right next to the SN. That implies the times in between. The pluses get carried down. And what we do now is you get rid of the multiplication matrices first, just like BidMath. And then once you've got the answers, so if you multiply the transition with the original or the year before matrix, what you get is this answer down below. The baby blue matrix of what the company does at the end of each year, where they buy no eggs, buy 200 baby Whitings and sell off 500 adults to the restaurant. That still stays the same because it's got pluses on either side. These two get simplified down to just 50,000 eggs down below. And what we do is we add them all together. Once we've added them all together, we've established our answer of 50,000 eggs, because 0 plus 0 plus 50,000, 50,000. 6,000 plus 200 plus 0 gets us 6,200. 1,700, take away 500 because minus overrides plus. You get 1,200, and you got zeros here, so that makes no impact. And lastly, you've got 16,800 deaths. Oh, I wrote dead. Well, dead and dead. Death, pretty much the same. So back to the question. What was the question? We probably forgot. How many eggs will there be after the first year? How many eggs? Well, looking back, it's pretty colourful. So how many eggs do we have? We have 50,000 eggs after the first year. All right, and that is it for Year 12 Further Maths, everyone. Congratulations again. So many people want to be in your positions, but they aren't. And congratulations just by making it through Year 12. Unless you haven't done the SNN tasks, then there's a high chance you probably will fail if you don't get them in. Or there's a 100% chance you will fail if you don't hand in your SNNs. So I'm still waiting on a few people to do that multi-choice quiz. Remember, if you do it, you get an S. It's literally fail-proof unless you don't open the document, which some of us have chosen to have done. But remember, the SAC is on Thursday, week 8. We're in week 6 at the moment, so that gives us a week and a bit to revise for the SAC. And I urge you to make sure you've done all the questions from chapter 8 and chapter 9. And what we'll do is we'll do one more SNN task, probably next Thursday. Yeah, next Thursday we'll do another SNN task. It'll be Ed Rollo based, so if you want to knock that out, feel free to, but make sure you've done actually all the exercises beforehand. Otherwise, it's going to be a waste of time. You're going to look at the questions and be like, what the hell is going on? Otherwise, just trying to think if I missed anything. I'm sure I have. Please just make sure you email any questions. And yeah, that's it. That's all for the content.